Okay. All right. So I'm just going to do a sort of a wandering tour through a bunch of things that have been of interest to me that seem to intersect with what this thing is about. So it's going to be a little meandering. So some of you probably know this. This is the Heider-Simmel wonderful little experiment from 1944 in which basically they demonstrated that you can take the most incredibly simple shapes very, very minimal visuals and tell very, very compelling psychological stories. I'm not going to play the whole thing through because I think I'm going to run out of time. But basically, you've got these two cute little characters, and then you got this big bully character. And in the course of about a minute or so, the big bully ends up just terrorizing the little characters. And you end up really feeling this very powerful set of attachment, and you root for the little guys, and all kinds of stuff happens. But it's really just like incredibly simple shapes. So I've been inspired by this. And of course, there's also similarly the Disney flour sack animation, where they say, okay, take something incredibly simple and just try to make it compelling. And so I sort of have this modus operandi in my research, which is similar to what Nick was showing with his little micro story, in that I say, what's the smallest, simplest possible thing I could do that exhibits some behavior? Because now you have a system that you could actually ask questions of because it's not overloaded with super complication. And so I've sort of done my own little versions of this in 3D computer graphics as what's the simplest possible character I could make in 3D graphics that anybody would actually care about. So this is, 6 vertices, and it's just, and you can actually see I'm just triggering little procedural animations. So here, this little guy suddenly comes to life. It's walking, or maybe it's like really full of itself, like, yeah, I'm really cool, or exercising or something, or maybe it's on the hunt, And these are all just these subtle little variations. It's very sad, maybe. Oh. Or you can ask it questions, and it can say no, or it could say yes. Or you could imagine that this transparent plate that it's on, we heat up the plate, and then, of course, it gets the hot feet. Or it like runs really, really fast, or it hops on one foot. And what's interesting is about 20 seconds have gone by, and you've developed an entire relationship with basically a little piece of red cheese. And that's really intriguing, because that says more about us, our culture, our psychology, the biology of how our brains work, than it says really about computer graphics itself. It means that, as Janet says, believability totally rules. And to paraphrase, what?
And Joe Bates.
Well, right, and Joe Bates totally rules. That's right. So I've been following this muse for a while, and I started at some point asking what other characters could inspire me, to do these kind of things. So I got to this character, who's a very, very inspiring character, and just like this pure, like, I'm totally there with you character. And in fact, it's interesting because he has like a little pet goldfish, and you just know he loves that goldfish. And at some point I started thinking, it would be interesting if instead of thinking of Elmo and his goldfish, suppose Elmo was a goldfish. And I thought this is kind of an interest. So I spent lots and lots of time just looking at Elmo, for inspiration, and staring at him, and then ended up building a little thing that actually was about some of the stuff that that Noah and Michael and I and some of us share in common. And this is an app that's running on the web, and so it has basically these little numbers on the side basically mean it's got 42 different possible stories you can tell. It's 42 in honor of Douglas Adams, so long, and thanks for all the fish. So here's one I just cleared out before we started. And the basic idea is very simple. How can you push up puppetry to the point where the puppet is smart enough that you could do a real-time performance of a little movie, and so that you have a very simple interface because the puppet's doing all the rest of it. And then at that point, that means that we've got a character who's semantically smart enough that we could start doing very simple, discrete AI, and interesting things might happen. So it's kind of the same sort of question. Like, for example, if you notice there are little letters here, like the letter H means he's happy, and A means and then he's unhappy, or eh. So you can kind of see how he's like, I'm puppeteering at a high level. He's really just this mesh, that I'm just procedurally animating. So you could imagine telling a little story with this. So we start a little timeline going, and we say, oh, he's investigating the world around him, and he says, looks at the ball, and and nothing happens, and so he gets really sad, like nothing's happening, like, oh, nothing's happening. How come nothing's happening? How about the other one? You know, nope, 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 nope. And then meanwhile, of course, we make the ball bounce or something, you know, behind his back. And he turns to look at it, and he's like, "Wow, that's so cool," you know, and like, we're really happy now. And then he turns to the other one, but of course it's like, it's unhappy again, you know, and then he turns to the first one and the second one and the first one. Of course, then we kind of make this one bounce too, you know, and he turns to it and he's like, ooh. You know, and so now he's really happy, and he looks at us, and we're like, we're having a really great time, you know, right? So this was a little, I could make many different movies. In fact, all the people who've gone online, it gets saved to a server, they just make their own little movie. And then what's really cool about this is you can go back and you can say, oh, I wanted him to go, ooh, a little earlier. I can edit this thing now, because it's so simple now, because I only have a few variables over time, that I can start like just right here, change it. And in fact, if you went to this web page and you went to story 33, you and I could be doing this together in real time. So there's this run mode and there's this edit mode, et cetera, et cetera. And I can, you know, I could go back and I could, you know, I could play it again, and as I'm playing it, it'll play out the same movie, because it's a very simple script, except I can be editing it while I'm doing it. So this is a paradigm for trying to push the smarts of how things happen into the character. And I started wondering at some point whether I could do this with other kinds of things. So for example, as I mentioned at the beginning of this conference, I'm sort of fascinated by Jane Austen. And I thought, could you do this with Jane Austen? So I started trying to apply these kinds of techniques to Jane Austen. I said, what would, you know, cute little performers, you know, there's the whole upper class British sort of, you know, character from Regency England, you know, that they remind me of. I started to create characters that reminded me of this. So this is the I hope British people are not too offended by this. But basically, they're sort of like into themselves, and they're really, you know, they have this whole sort of like, you know, one character, everyone looks at the one character, you know, social approbation. They use big words and stare at each other. Or you could then have them, or you could make a participant. So I'm just moving my mouse around, the character is kind of like moving. And these, you know, one would be, you know, Elizabeth, one would be Darcy, one would be Jane, one would be Mr. Collins, you know, and you'd map them out. And I started making interactive stories of them. Or you could make it participatory, like, you know, like weird bird-like creatures of the damned. You know, they're looking at us. But then I started realizing this maybe isn't rich enough for what I'm trying to get at with Jane Austen. And so I thought maybe I need to, as the humanists would say, go to the text. So I decided, let's go to the text. And so here's the text. And I started thinking, how would you rethink the book itself? So this is the book. This is a Pride and Prejudice. What I did here is I threw out a 2,000-year-old innovation because we don't need it now that we have screens. I threw out the page, and I just went back to before the codex and replaced that with a scroll. So this is one long continuous scroll. It's, you know, 3/4 of a megabyte. It's 61 chapters. You can see the chapter markers there. And this is the whole book. And so now you can start asking questions about the whole book. And I found as soon as I did this, I really started learning things about Pride and Prejudice that I had not realized. So, for example, where does Elizabeth show up? Well, there's all the places Elizabeth shows up, you know, and you can actually see the individual words. I hope it's showing up there. And you can go to different places there and ask questions about it. And you can ask, and she, of course, she shows up everywhere because she's the heroine of the romance novel. And they say, where does Mr. Darcy show up? I made him blue. And Mr. Darcy, interestingly enough, doesn't show up just everywhere. He kind of shows up and disappears, because he is the elusive object of her desire, and the reader is supposed to identify with that. So entire chapters go by and no Mr. Darcy, you know, and you go crazy. And but an interesting thing happens right in the middle in chapter 35, right in the middle of the book, when you superimpose them, you say, where are both of these people? And it turns out in chapter 35, they both disappear entirely. It looks like there's a mention of Mr. Darcy once here, but it's actually his dad, so it's not actually him. And what's happening in chapter 35, does anyone tell me what happens in the middle of the novel that changes everything? Somebody writes something. The letter. He writes her the letter, and she reads the letter, and all the reasons she thought that she like hated him, she now understands. And of course, she's now free to like understand he's really a sensitive soul and fall in love with him. So if you actually look at Pemberley, which is a big fancy estate because he's a rich guy, so she wins if she marries him. If you look at it as a game, it's mentioned in the beginning here. You know, it's mentioned once, one word, and then it's a cluster here, and then it disappears completely. And then soon after she reads the letter, she goes and visits the estate. And that means, okay, everything's going to be great. It's going to be like, it's going to be mentioned a lot at the end. Everything's going to work out for them. Sorry if I, you know, messed up the ending for anyone who hasn't read it. It's really a tragedy. They all die. It's terrible. So you can ask all these questions, and also then and then I started doing things like, oh, let's just pick any word, and you could actually type the word or highlight it, and like this is the word country shows up a lot on this page for some reason that I'm sure somebody would find very interesting. And I thought this idea that you can just see, the thing that excites me about this is that stuff there is a map. Think Google Maps. This is the map of the novel, and because I got rid of the extra space that the pages, which are really inessential and change edition to edition anyway, were getting in the way of showing, you could have multiple people commenting on the text, and you could see the map that they can all share as a common place that they can talk about this book. You could have textbooks where the teacher says, oh, I see everyone in the class is sort of having a problem there, and there's a direct line between having there and there, and start using your own visual sense to start explore these narratives. Once you can see it all in one shot, it gets much easier. And then I started thinking, wouldn't it be great if we could start manipulating this stuff? So I added a kind of a procedural level. So this is kind of a behind-the-scenes script. You notice that the chapters are different colors. So this is basically stuff I started doing simple version of this, and then I saw Brett Victor's brilliant video about smart text, and it completely like whoa, got me all excited. So I started doing things like that, where you started saying, oh, go up to the text and just, this is an interactive widget for defining a color. If I apply this, then it immediately applies that, and it's just rerunning the text. And you can do the same things with the name. These buttons up here are defined the same way. In fact, if you go and you have some, like, if it knows about some special color, and you do that, then it sort of now knows that you're talking magenta, goes in, it does all the stuff you're supposed to do. It like finds the special cases if it can, lets you go into the general cases if it doesn't find that. So this is what's supposed to happen, the simplest possible representation, and go back to the the RGB code, whatever. So this is an approach to doing things that then started me thinking, maybe it's not virtual characters versus the text. Maybe there's some way I could bring them together, but then I had to do a lot more work before I could actually bring them together. And the way I did that was by starting to get really interested in augmented reality. Which seems like a bit of a contradiction. So we go from Jane Austen to Vernor Vinge, who, how many people have read Rainbow's End? Okay, really awesome. About 30 years in the future, more or less, everybody's wearing. What are they wearing? They're wearing things that, this is an artist's conception, the things that look like this, you pop these things in your eyes, and suddenly everybody, can have a shared augmented reality experience. So think Princess Leia and the Beam of Light. Most of you are old enough to know that. But just floating right here that we all share because we have futuristic technology that's ready. So it'll be not Google Glass, but way, way beyond that. And so we started doing all kinds of experiments in our lab. We had the students using the Microsoft Kinect. And I'm not going to use the Kinect in this talk because I don't have time. It would take much longer to do the Kinect thing. There's too many steps. So you'll just have to sort of see the videos, and then I can show people a demo later of stuff with the Kinect, where we would do things like say, okay, do an augmented reality presentation, but the rule is that everything you show must be real time, even camera cuts, no post-processing, no post-production. So here are some student projects. I'm working with Hiroshi Ishii, so the first student you're going to see is Xiao Xiao. This was a SIGGRAPH thing. Xiao Xiao, I'm going to skip past this one in the interest of time. Xiao Xiao is a student of Hiroshi Ishii at the MIT Media Lab, and hopefully this will work. And
how do we depict the 3D information from a globe onto a 2D map?
So it's all happening in real time.
One way of doing this is by drawing a cylinder around the globe that's centered at the equator. We project the globe onto the cylinder and simply unroll the cylinder to form the map. This is called the Mercator projection. One useful thing about the Mercator projection is that straight lines on the map correspond to great circles on the globe, which made it especially useful for navigators to plot straight courses as they sailed the oceans.
And this is Murphy Stein.
Maps are a kind of map that shows elevation. Let me show you how. Let's see this map in 3D. And let's make it bigger. And let's make it steeper and also add more contour lines, which correspond to the steepness. Now let's crush it back down and bring it back to a topographic map and add color, which can show the absolute height, which contour lines alone can't do. Bring it back down. Now let's rotate it towards you. And now let's fly over the region to see how the colors and the contour lines change together to show the shape of the region. Cool, huh?
So there you go. So everything you were seeing, the rule was write what they were seeing, process right there, goes to the camera. That's what you see. No post-production trickery. So let's see. Does this? Okay. So now, at some point, what we realized was that this was really cool, except that it was very difficult to author. So we started going back and started thinking about the live coding again and said, why don't we rebuild the system from the ground up so that it's easy to make these augmented reality things by invoking live coding. So let's go to that. Oops, let's go there. And let me see. Now I'm gonna show you some. This is like command line stuff because it's sort of more primitive. So this is a rebuilt system, what you're seeing here is now designed to be a presentation tool. Actually, just a little bit behind the scenes. I'm not going to show you the connection. You can't see it, but you could sort of get a sense of this. So the rhetoric we had here is that you're doing kind of two-way video chat. So think about Skype or Google Hangouts, but you're seeing me and I'm seeing you, and we're seeing 3D objects floating in the air between us, and we're both manipulating these 3D objects. So that's kind of the idea of what we think we're doing here. And here you can see the person who's drawing this 3D object can see all these helper lines and things, but the other person can't. Think like RoboCop or Terminator or Iron Man or other highly non-feminist works. So this will give you a sense of this is my view with all the different power-ups. I have my little help thing here, blah, blah, blah. And this is what the person I'm presenting this to, much cleaner. They don't see all the little extra stuff that I have. And then this is actually the live coding, so I can go and make any changes here that I want. So for example, let me show you this. So for example, this is the code that's making this thing happen. And there are certain things we had to do to make this happen semantically, which are really unusual for computer graphics. So for example, if you change this from a ball to a box, then notice that guy changed shape. So you can just change anything anytime you want. And we also had this notion that as I'm explaining something to you and I'm waving my hands in the air, we have these secret power-ups. So basically, as the person's waving in the air, and if they were connected, you would actually be tracking the hands. They could be saying, "Oh, I wanna tickle this guy," and he goes and he tickles him, and he's actually going over this hidden button that notice that other people can't see. Oh, let me change this back. By the way, we also have this idea of being able to sort of put widgets right there. So let's change the box to a stick or to a ball, and it just changes immediately. So these ways, these power-ups, or I want to make it taller, so you can make a tall gesture or a short gesture, and it's actually doing a power-up. By the way, this is actually a fairly complicated object. You see it's made up of lots of little objects. There's the loop right there that's building all these objects. The weird thing about what you're seeing here is that from the point of view of the person making this, every single bit of this complex model with lots and lots of polygons is actually happening inside of the update loop, which seems like it should be too slow. So the idea of allowing people to do live coding for a 3D modeler involved the radical change that you present the designer with the fiction that they are rebuilding the whole model every single animation frame. That way, all their controls to build a model can be completely interlaced with all their controls to animate the model in exactly the same place, which is much easier. Now, sorry if this is getting too technical for some people, but it's crucial that that this, of course, can't really happen. If you actually had to rebuild all those polygons and allocate all that heap space and everything, the whole thing would grind to a halt. So the trick is that you build the model every frame, but you already have the model. And so as it's running through this, basically this is interpreted Java, which is actually implemented by Pat Niemeyer back in 2005, and I'm using it because he makes it available, which is wonderful. As you're building the model every frame, if you're building the same thing that already exists the previous frame, you don't have to do anything. You're just going down the tree and not doing any work. So you can give people this incredible sense of freedom without it actually slowing down to a halt. It's basically just like a display loop. And this means you end up doing enormously powerful things. In fact, I'll show you some other examples. Let's go. So for example, let's say you also add some procedural stuff. Like you can see the behind the scenes here. Okay, and the behind the scenes, which you're seeing here, is what I see if I'm waving in the air to tell a story. And then what the person the other person sees is on the right there. And here I'm going to make a procedural object, and we bring in some powerful procedural tools. So we start with some very simple helper objects. We assemble them together, and these are just simple. And basically, this is a blend shape. This is real-time isosurface blending. So you can sort of take these shapes and blend them together, blend shapes and colors, and then you can start doing things like change the position, add a little procedural stuff, and make your little guy fly off. So these kinds of stories are very easy to tell while you're in a video chat with someone in augmented space. And the reason that they're easy to tell is that you have these power-up tools that make it very easy to do this stuff. So let's go, for example, if we want to make a little bear. Okay, so now in the hidden story here, I can wave in the air to turn this guy, but actually I'm going over this button. In fact, I could always hit the R key. In fact, he's a procedural bear, so you can actually see that I get a little hidden menu that the people who are looking at it don't see. So in fact, if I hit M, he just melts, which is really sad. So. Woo. Okay, so, but now, and that's because he's actually a blending together of what are actually, in fact, here's all the code that does the blending together. If I get rid of that code, you actually see he's just a bunch of separate shapes. But then because I have these modeling power-ups that give me all this extra capability, I can say, oh, just infuse that all together, so it looks like it was done with a very fancy modeler. But now, what's really cool about this is that because he's entirely a procedural model, I can actually go and modify these underlying shapes and change the code then and there. So for example, let's take the, let's change a parameter. Let's change this parameter. Okay, so we're changing a parameter, and this is changing like how fat he is. So that's changing a bunch of things. And you see he's actually getting fatter and skinnier. So now he's lost weight, now, and now he's a skinny bear. And now maybe we gain weight, gain a whole bunch of weight, and now it's like he's gone to some conference in Santa Cruz where they fed him too much. And what's really cool is that this whole trend that a lot of people are doing of live coding, I'm going to tell you something really, really important, which is that for decades, my IDE has been VI. I write code by typing VI and then typing Java-C. This is how I program. In the last 2 months, I've stopped using VI to do any content-related work because even with this stupid, simple editor, the fact that I can make the changes right then and there has just been completely transformative for me. So if I have this guy and I want to say, oh, gee, I want to change his color, I can just go in real time and just pick colors for him. And it's happening while things are animating, while everything's going on, he's doing all of his stuff. And it's so much more productive to live in a live coding environment that I thought they were going to have to like drag VI out of my cold dead hands or something. But no, it's just, hey, you make changes in real time, you go there. So this is a very, very important thing. So let me give you some other examples. I alluded to this example somewhat briefly in, hold on, I have to do this. In that picture that I showed you. So, so here, for example, this is the behind the scenes. If I were drawing in the air, here you can sort of see this is what I see, but the other person doesn't see, and I can sort of draw a profile, and then it goes into a little procedure that sort of makes a lathe object, direct product of two shapes. You can even do the really cool thing where you you do the lamp that's like there's a face. Whoa, I'm doing a really bad job of this face. Sorry, I'm really bad at drawing with one of these non-mouse things, but let me do it again because that really sucked. Hold on. There's a nose. There's a face. Okay, good enough. All right. So there's the kind of the two profiles facing each other thing. But what's really cool about this also is because it's all live coding, I can go and I can say, I really, that thing I actually it's as though I just typed these numbers in right here. When I did that, those numbers changed. I defined a new path. But I can now go out to this and say, hey, let me just define these guys. Oh, that's convenient. So now I can go and I can just start moving this. And notice it's changing the numbers in the code and changing the model in real time. So you have these kinds of power-ups. Once you do this, you can build whatever widgets you want. It's really, really convenient. And so now that you've gotten the basic idea of this, let me show you one last example because it turned out that I don't want to just do modeling and animation. I also want to do AI. I want to do things like character walks into a room. 3 seconds later, he looks somewhere. And half a second later, something happens. He turns back the other way. Traditionally, in these algol-like programming languages, Java or Python, it's really hard to do this kind of asynchronous stuff where I'm saying in my code that something's supposed to happen later. And in Java, it's really hard because you can't, what some people call, people who do studying programming language call lambda expressions, like packaging up code and just having a little bubble of code that I can execute later. It doesn't support that, or at least doesn't yet. So what I've done is I've extended the programming language. And so here, for example, is if this works. So this is a little loud. So this, let me turn this. So this is a little procedural xylophone. Uh-oh, it crapped out. The problem is that I'm using Java sound, and it just keeps crapping out. So I'm just going to start again. Oh no, we're running out of time. So let me see. Do I have time for everything? Yeah. So I'll go really fast. Okay. Okay. Hopefully this will work. And you'll see, so the key is that if I go down here and I make a change, for example, this is a minor scale, some of you will recognize it, and if I make that a change, of course, I can make it a major scale. So, I can make easy changes like that, minor scale to major scale. But then what's more important than that is what's happening here is that every time I go over this guy, I trigger this play note. But now I'm going to add things that don't exist in standard programming languages. I'm going to say, oh, after a quarter of a second, package up and play another note. And after half a second, package up and play another note. So this, you're not supposed to be able to do this, but I've extended the language to add these do something later events right in it. So if I comment this stuff out, then you can see that if I play this, and in fact, if I go and I change this to a different pitch, oops. And they're all happening independently, so I can do lots of different things. It's really cool. And so those of you who do animation will realize that this means that I can put my modeling, my animation, and all of my little AI signals for things to happen later in the same place. And that makes it reasonable for somebody to use programming to start doing content creation. Otherwise, I don't see how I would want to convince a young person to do Java to do animation, because it would just be too weird and abstract to have to learn all of the things that I have to learn otherwise. So I want to briefly mention then also that that one of the things we're also doing in our lab is using these really, really cool devices. So this, for example, is a device in our lab, which is actually much more powerful than the sort of ProCap that you get from, let me see if this works. So, oops, wait, am I in the right place? There we go. So this, for example, what you're seeing is what's going on here is this device is an anti-aliased pressure sensor. So even if I just put my fingers there and I wiggle my fingers with no visual movement, I get much more powerful movement. You can't get this with the standard stuff. So we're interested in richer forms of input that let you do more artistic kinds of things. In fact, I'll just give you another visualization of that. So here's the same thing, but kind of visualized in a different way. So here's a rubber sheet model, and you can put water in it, whatever. You make little mountains, all kinds of stuff. So this becomes a much, much richer way of doing things. And we're interested in doing these more performative things. We have these rich input devices. So I'm going to end, because I'm kind of running out of time, by showing you at the very end. I'm just going to show you. I'm trying to put these things together. So. And here's the attempt so far to put these things together. There's our little teddy bear friend. He's now in a book. This happens to be Winnie the Pooh. It seemed appropriate. And here you're seeing, as you can see sort of on the right, you're going through the book. If you go there, you're going through the book more quickly. I'm just scrolling, through this book. It's only partly implemented. For example, you see that in the little view there. I don't show him yet because I'm just, starting to build this stuff. But now we have our own text editor from the ground up. And this means things are much more powerful. For example, I can go to the code, and I can go right up to the code, and I can say, hey, I want to change his height. And as I do that, I don't have to build another special kind of widget. I can just go ahead and do this right here. Or I want to change the color, his color, and I can change his color from blue to, does that work? Nope, I think I broke it. Oh, there, brown to orange. There you go. Oh, the reason it didn't was because I had actually defined what my color space was up there. And if I change that, now I get a menu. See, now I can cycle through those colors. So the person who is writing this gets to define all these things themselves if they want to, or they can use a library. And now suddenly, the hope here is that because illustrations are now embedded as living stuff, right? You know, you can do all the same stuff. He has all the same tricks. Like, oh, okay, there you go. Right in the text of the book, you can start doing these power-ups, like saying, I want to change the text of the book, or I want to have science simulations, or I want to have charts, or I want to count the words of the text and show me some statistics, and then I'll figure something out about the characters. And so our goal for combining this real live coding of 3D stuff with AI and everything, and the sort of characters that I think you're going to show too, with right into what I think is a rethinking of the book itself, basically means that my hope is that when kids enter high school at 14 and they have the book, which is going to look more like a tablet, but it's going to be the book. It's going to have all these texts and all this like stuff they can do. And then they can start having power-ups in the book. And maybe when they're freshmen, they're very simple programs. They're just a few lines long. But as they go through, they're learning more and more and more. And eventually, you can have this integrated into every single subject. And in fact, the whole question of how are we going to get our kids to learn programming, you don't even ask the question how to get to learn programming. You build the art class, the economics, the fashion, game design, history, language arts, math, music, sciences, everything, so that the book has a gradually more interesting set of the right procedural stuff that illustrates things. You make it communicative, like think Google Docs, like I'm doing this and you're doing this and we're building a project together. But you build it so deeply in the DNA of learning that of course everyone learns programming because, you know, you get this power up by doing it. So that's the world that I'd like us to build toward, and I think it's a good place to stop. Thank you.